1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d6. That was the number, right? Or 3d4 it was, 3d6. Now you need to see where is the electronic configuration ending for the noble gas. This is the configuration of argon. Put this in a bracket and go for 4s2 and 3d6. So this is the long configuration, detail one, and this is the short configuration, right? So everywhere when you see there's a noble gas, the configuration will be locked with that noble gas, right? Are we clear with that?
Yes, sir.
Okay. So when you see, let me share periodic table with you. And let us talk about this. Come on. They're sharing me the periodic table right now. I don't want that. I want a picture only. Okay. This is a periodic table with me right now, and I just want to share this periodic table with you. Okay, see this periodic table here. In this periodic table, if I just come back, here is periodic table. I'll just quickly take the picture of this. Okay, and then I'm going to share with you this so that I can write on it. Okay. Okay, here is the periodic table once again. Okay. Do you see this periodic table now? So when you're working on the periodic table, keep this in your mind. This is okay. Why it's not writing? Okay. Ah, yes. There we go. Now, when I'm writing the electronic configuration, C for the hydrogen. This is period number 1, and this is S. Period number 1 is not having any other S except this one. Okay, so the configuration end up with 1s2 here. Though helium is written there because its properties are mostly in the p block, this is a p block, overall p block. Okay, yani px, py and pz are completed here. Everyone will have how many electrons in it? 2 electrons each. Okay, when you see that the configuration reaches to neon, any of the noble gas, then you lock that configuration. Okay, now how to do this locking of configuration is, Okay, it is 1s1 and this one is 1s2. Now, period number 2, lithium will end up with 2s1. So this is 2s1. This one 2s2. Now this is 2p. 2p1, 2p2, 2p3, 2p4, 2p5, and this one 2p6. So 2p6, you are locked here. When I start configuring sodium, I will write neon in a square bracket, and after that I will write 3s1. For magnesium it will be neon followed by 3s2. For aluminium it will be neon, then 3s2, and then after that 3p1, 3p2, 3p3, 3p4, 3p5, and 3p6. Now the configuration is locked. Okay, so when I start potassium, I'll go for argon in a square bracket. Then after that 4s1, this is 4s2. Now 3d starts. 3d1, 3d2, 3d3. This should have been 3d4, but it is 3d5. This is normal 3d5. This is 3d6. This one is 3d7. This is 3d8. Copper should have been 3d9, but it is 3d10. One of the electron is jumping into 4s. And zinc is 3d10 natural. So argon followed by 4s followed by 3d. Right? Then 4p starts in this area. So gallium is 4p1, germanium 4p2, arsenic 4p3, selenium 4p4, bromine 4p5, and krypton 4p6. Now locked once again. If you go for rubidium, it will start with krypton square brackets. Okay, is this clear?
Yes.
Okay, this is also a short clip which I have recorded for you. It will be uploaded. If you want to know about it, go through it again and again, and things will be clear to you. Now, one thing more which I want to tell you, see the unpaired electron now. In this case, we have the unpaired electrons. See the unpaired electron here, 3d is not paired up. Now when 3d5 is there, it means you have to do something for it, like you need to draw this structure and to see what do we mean by 3d5. So 3 electrons are there, 2 electrons more, so 1 unpaired is there in it, right? Are you clear with this? If you are working on 2p6 or 3p6, draw the p, 1 2 3. Okay, 3d5 means like this. Okay, I'm sorry for this. I thought it for
Yes,
took it for 3p actually. So it will be 1 2 3 4 and one more, 5 electrons will be there. Okay, so they're all unpaired. And for 3p, of course, 5 electrons, 1 2 3 4 and 5, 1 unpaired electron is there for it. Okay, any question related to that?